All right, so good afternoon, guys. Good afternoon. Can you guys hear me?
Good afternoon po.
Good afternoon, sir.
All right, so uh, I hope that you guys are okay. That you know, basically, your brain was exhausted, basically, with our Kirchhoff's law or module number 2 discussion last meeting. But I hope that you guys were able to understand what is Kirchhoff's law all about. Anyway, so for today's meeting, we'll going to discuss module 4 and module 5. So Maxwell and then superposition theorem. Okay, so don't you guys worry. Once you totally learn Kirchhoff's law, applying Maxwell loop is already super easy. Okay, so that is why this is the main foundation of this Maxwell loop, and yeah, maybe superposition theorem, but mostly superposition theorem is connected with Ohm's law. So let's just say that if you haven't learned anything about Kirchhoff's law, you won't be able to answer Maxwell loop current method. Okay, so I encourage you guys to really study this one. Okay, completely study the module 3 before jumping to the module 4. All right, but before that, so I just would like to just remove this one. Okay, so just would like to show the answers with your assignment, exercise number 1, and then quiz number 1. All right. So starting with assignment. So this is the 10 point. So I guess this one. All right. So the correct answer for the assignment wherein water heater has a resistance. I hope that you guys can see this one. Has a resistance of 5.3 ohms and takes 43.5 amp when in operation. If it is in service on the average of 2 hours per day, how many kilowatt hours of energy will be expended during a 30-day month? So the correct answer for this one is 601.74. Okay, so let's see the solution of Mr. Baltazar. All right, so from here, where is that solution? So energy is equal to the solution. So 230 is your voltage times 43.5, okay, times 2. Where is our formula? Okay, I need the entire formula about Mr. Delacruz. So let's see his solution. So you also get the correct answers. Correct answer, since there's only one. Sorry. All right. So we have this formula, okay, I squared times R times T. So just substitute the corresponding values. Okay. So I is 43.5, so square that one. And then R is 5.3. And then the time is 2 hours per day multiplied by 30 since we're needing 1 month. Okay. And then divided by 1,000 for you to get the kilowatt. Okay. And then you will get 601.74 kilowatt per hour. All right. So any question or clarification so far? Well, most of you got this one correctly, but there are others who wasn't able to get the correct answer. Like this one, I'm not really sure, but I might consider this one. Okay, so I haven't checked all of your assignment number 1 yet. So if your answer is really close, so I have to check your solutions first on why or how did you get 68 instead of 74. Okay, so here's the solution for the assignment number 1. So are we clear so far?
Yes, sir.
Yes po.
Any other complaints to those who haven't get the assignment number 1? So you can check your solutions once again on, where did you made a mistake. All right, so that's it for the assignment number 1. So let us now proceed to the exercise number 1. So in here, I think half of you were able to get this one, or maybe no, maybe 40%. The three others have got average 20, 16, 14. But there is one who got this one. Is Michael. Where is that one? Here. So the one who got a perfect score is Mr. Michael Alfarid. So are you here right now? See, he's here. So basically, he only got 24. Okay, he made. So there is a difference when it comes to answers. Wherein you've got 19.02 and 0.36. So this is my mistake. Okay? So his answer is 0.36, but the correct answer is 0 divided by 36. So I already made the correction on this one. Okay? So I already changed the correct answer. So for this one, this will be counted as a correct point since the correct answer is 0.36, not 0 divided by 36. So this is a typo error in my case. And then for the last one, so the correct answer is 914.40 or 914.4. But his answer is 912.96. Well, that is because we've used two different uh, values, which is in my case, it's 19.05, and then in this case, 19.02. And both of them are correct. So I've just considered this one as correct also, since the answer is super, super close. Right? So let's see the solution of Mr. Michael. So there you go. So he actually completed the entire circuit, wherein maybe he uses 119.02 or 2.52333. So that's where now we get the different answers. However, those two are still correct. Okay. And for the power, so right here, it's 19.02 times 48, so we'll get 912.96. But in my case, I've used 19.05. That's why I've got 914.40. All right. So yeah, I guess this one is very straightforward. So just get the R total first. So R1 and R2 is in series. So just add those two. R1, I mean R4, R5, and R6 is in series. So just add those three. And then parallel the this section to the this section and then this section. Just like this one. Okay. And then you will get 2.52. And then from there, once you already have the R total, that's the time that you can have or you can get the I total. Okay, so V divided by RT, so 48 divided by 2.52. So this is also one thing wherein I've only used two decimals all the time. Okay, so that is why you've got a different answers. Okay, both of our answers are correct. However, yeah, next time just use two decimals. Okay, because especially in your exam, if I mentioned that you should strictly use two decimals all the way, okay, from the start up to the end, then you should only use two decimals for you to really get the exact answer. All right. And for the voltage drop, so just get the individual currents. Okay. Sorry. Since this one is in parallel, all right, so this one is super easy already. So this is like a bonus already. Okay, for you to be able to get the VR1, VR2, VR3, 4, and 5, and 6. So whatever is the voltage or your total voltage, that is also a voltage drop across those nodes. right? So that's why 48 volts all throughout the circuit. And then for the currents, so just divide it by their individual resistance, wherein for say I, R1 and R2, we have here a resistance of 18. So whatever is the current of your R1 is the same with the current of R2. So that's the rule in series. So the same with R4, whatever is the current that is flowing on R4 is the same with R5 and R6. Okay, so here's the value of your IR1 and 2, and then here's the IR3, and then here's the IR4, 5, and 6. And then for the total power, so we have a lot of formulas. So we can have P is equal to I times P. We can have I squared times total resistance. You can have E squared divided by R. Okay, so you can use any of those and then you will get the same answer. All right, so are we clear so far regarding the solution of activity number 1? No, guys. Diyan pa ba kayo?
Yes, sir.
Sir?
Yes, sir.
Sir, question, sir.
So, are we clear so far with your solution on exercise number 1?
Sir, may question ako, sir.
Ano yun?
Sir, yung VR1 tsaka VR2 pares lang?
Whatever is the voltage across this entire node is the same with the entire or other nodes. Kasi sa parallel naman to eh.
Sir, I mean, sir, yung dun sa section mismo, sir, yung like yung individual resistors pares ba sila ng voltage?
Ng R1 and R2?
Yes, sir. Pares ba sila ng ano? Di ba, sir, nagkakaroon ng voltage drop pag naka-series? Parang pag pare sila, sir, 48 sila, pero hindi ba magkaiba sila pag mag-individual?
You mean the voltage on the R1 only?
Yes, sir. Kasi yung question, sir, dun sa
Binigay ko
ano,
dito.
yan, sir, VR1, VR2, VR3. Sir, di ba, kung by section, sir, di ba 48 sila talaga? Pero
Yeah.
kapag individually, sir, di ba magkakaroon ng voltage drop since naka-series yung V1 tsaka V2?
Yes.
Tapos
So
yung
the
V4, 5,
voltage,
and 6. Ganun kasi yung ginawa ko, sir, dun sa akin.
I see. Because that 48 volts will be, of course,
Divided pa
separated.
dyan.
Yeah, separated between those two components. Some will go to the R1, and then some will go to the R2, so depending on the resistance. So what is your solution?
Sir, hindi ko lang alam kung tama. Pero
Let me see. So you've got 16 out of 30. Wait, let me just reset it. Sometimes there's a bug where I cannot download any file.
yan, sir. Sa,
VR1 is
sir, yung mga section 48 sila, pero pag kinuha yung voltage,
48.
tingnan ko. Ganyan yung ginawa ko, sir. Since yung question kasi naka VR1, VR. Pero kung section lang, sir, yun lang.
If it's just a section, then all the way it's 48 volts.
Yeah.
If it's one component only.
Pero nagulo lang ako dun sa question, sir. Kasi,
Ay, sir, ano po kasi? Sir, medyo magulo rin po kasi gaya po ng sabi ni Samuel. Doon po kasi sa question po. voltage in each section, pero pagdating po dun sa canvas po yung fini-fill up po, V1 to lahat po nung lahat po nung voltage
Oo.
numbers nakalagay po.
So
Kaya, sir,
the correct answer is 48 all throughout, since it is asking the section of R1 and R2 at the same time. But
pero
in my
sir,
case, I just separated it. So that's why it became like, individual resistance, not the individual sections. So the correct answer is 48. Okay. But
pero
if
isa-isa ko, sir.
yeah. If it's one by one, your answer is correct, Mr. Santa Cruz. Okay, so sorry for that. My mistake. However, the question is section.
Sir, nakalagay
H.
na sa solution ko, sir. Nakalagay sa solution ko dyan lang sa sagot. Yan, sir.
Sir, I
Section
think
48.
it's because in the filling the gap, we didn't have section. We only have V1, V2, V3 as if they are individual.
Yeah.
I think that's why it was confusing.
Yes.
Because I think I did the same thing.
You did the same thing too. All right.
Yes.
So I'll think about it. Okay, if I will consider
Okay.
the individual resistance.
Okay, sir. Thank you, sir.
Follow right? Follow ABCDEF. So we got 16 out of 30. Cannot download again. But why do you have 0.36 volts? I think you made a mistake. I1, 2, where is your I1? 2.67 times R1 and 2 is 118. Really? It's 2.67. 2.67, but for the R1, it's times 6. I see. We've computed the VIR. Yeah, you multiplied it using the Ohm's law in, it's V times I times R. However, since it's in parallel, okay, so we don't do this kind of solutions in parallel, because whatever is the total voltage or the voltage source is equal across on each section. So that is why your answer here is quite far already. If you're going to add the V12, V3, V4, 5, 6, you'll not be able to get 48 volts. Well, in fact, this one is super far to get the 48 volts. This one is only a total of less than 6 volts. Am I correct, Mr. Falabeba?
Yeah.
So that is why you guys really have to strictly follow the rule. Okay? Wherein there's only 2 rules. So for the series, this is the only equal parts, which is the current. And then for the parallel, all the voltage across your sections are equal with each other. Okay, so you don't need to solve anything on that. Just whatever is your E total, it's the same with your E1, E2, and so on and so forth. Okay. Anyway, so I'll just maybe consider the others who answered the correct individual resistance. I mean, individual voltage drop for the V1 up to V6. Okay, so just check your score again, maybe tomorrow or the next day. All right. So yeah, that's it for the exercise number 1. And then for your quiz, oops. So let me just check. So most of you got a high score in your quiz number 1. So very good. 14, -2. All right, so your highest is 126. I guess there is 126. The other one, one of them is Miss Tegan. We're in 22. So I have already considered this one, okay? Wherein I made this 122 out of 22 points. And this one is also considered, I guess, because I have already checked your quiz number 1. This one is 2.5 also. I guess I have already checked this one also. 22 points. 22 out of 22. 20 out of 20. 16 out of 16. 12 out of 12. 4 out of 4. 4 out of 4. 12 out of 12. 10 out of 10. How come that you've only got 126?
Yung sa solution po kasi na ano, sinend 4.4 yun.
I think this is the bug. Okay, so as you guys can see right here, supposedly there is 11 questions in your quiz number 1, wherein I put 4 points for your uploaded solution. So this is supposedly the bonus one, but then that part in your quiz didn't showed up. Okay, so as you guys can see, the uploading section right here, which was supposedly right here, is not in here. So that is why she've only got 126. All right, so I will recheck this one once again. So I thought that she've got another incorrect answer. However, she've got a perfect score. So let me just show to you guys her solution. Naintindihan nyo ba, guys? Miss Tekligan, are you here? Miss Tekligan. Yeah, I cannot see her. Maybe she's not around. Anyway, so let me just look for another better handwritten for me to be able to show the. There you go. So Mr. Gangas also got a perfect score. I guess, yeah. 126 out of 30. So let's see his solution. All right, so I guess this one is a little bit better. Okay, so for the number 1, so I guess this one is super easy. R total, I total, I1, I2, I3, V1, V2, V3, V1, V2, V3. Okay, so the solution for that one is right here. Can you guys see? Or not clear? Hello? Can you guys see the solution?
Yes, sir.
Okay.
Yes,
So
sir.
for the R total, just add everything. Okay. We're in 20 plus 30 plus 50 will give 100. For the I total, of course, just use the formula V divided by R total. So whatever is your voltage source is write it as your V total, and then the R total is 100. So 125 divided by 100, you'll get 1.25 amps. And then for the currents, so since this one is in series, so we have this rule wherein I total is equal on every part of your components. I1 is equal to I2 is equal to I3. So that is why everything is 1.25 amps. Okay. And then for the voltage drop, so in here, just use the individual currents or individual resistance, but your I1 is equal with your I total, so you can just simply write here 1.25, 1.25, 1.25. So the only difference when it comes to solving things is the individual resistance. So for the individual resistance, we have here 20, 30, and then 50. So for the R1, we have 20, R2 30, R3 is 50. And then just do the math with your calculator, and then you will get those individual voltages. Okay, or individual voltage drop. So V1 is 25 volts, V2 is 37.5, V3 is 62.5. For the V total, so of course, it's equal with your 125 volts. So I guess I didn't ask this one anyway. Maybe he included this one as part of his solution. And then for the power, so you can use I times V, I squared times R, or E squared divided by R. Okay, and then you will get this individual power. So P1 is 31.250 watts, P2 is 46.875, and then P3 is 78.125. All right, and what else? P1, P2, P3. So yeah, that's it for the number one. And for the number two, so I'm asking you guys to create a schematic of this problem. So a kitchen in Cambodia has three appliances connected to 120 volts circuit with a 15 amp circuit breaker. So an 851 coffee maker and a 1200 watts microwave oven and a 900 watts toaster. Okay, so right here, draw a schematic diagram of this circuit. So which of these appliances can be operated simultaneously without tripping the circuit breaker? Okay, so the correct circuit diagram of this one is this one. So they should be in parallel so that your 125 volts are supplying each one of them by 125 volts. So you don't want to connect them in series. That's because the voltage that will follow on the next component will be lesser than the first component. So you don't want to have a dimmer or a lesser voltage which is supplying your other appliances. So that is why it should be in parallel connections. So this one is correct. So the second question is which of these appliances can be operated simultaneously? Wherein we only have a total of, where is that one? Sorry. Is this number two? 125, 21, or 50? 20, 50. No. So this is not the letter or number two. I guess this is still part of number one. Anyway, so this is the circuit diagram of number two. So we have here 850 watts, 1200, and then 900 watts. And then if you're going to get the total power, so it can only provide up to 1,800 watts. Okay, so that's the limitation of this current that it's providing, and then the voltage that it is providing. So in here, you have to do a combination of appliances. So it's a trial and error, wherein in here, if you're going to combine coffee maker and microwave at the same time, you'll get 2,050 watts. So this is a no-no already. So we cannot run those two appliances simultaneously because it's more than the power that we initially have. Okay, so the same with microwave and toaster. So it's more than 1,800, which will give you 2,100. But for the toaster and coffee maker, so 900 plus 850 will give you 1,750 watts. So that is why the toaster and coffee maker can be operated simultaneously without voltage interruption, okay, or wattage interruption, right? So the correct answer for this one is toaster and coffee maker. And then this is the schematic, okay, or the circuit diagram of the number 2. Okay, so are we clear so far up to this point?
Yes, sir.
All right, so for the number 3, where is that? Number 3. So for number 3, so I guess this one is no need to explain, very straightforward. So you guys already know that one. The same with this one, so no need. Same with this one. The same with this one. This one is just in parallel form. And for this one, okay, for you to be able to get the R total, just apply no more. What about the solution of mystic again? Anyway, so we can do this one actually manually. So if you want to get the R total, just apply. Where is our just apply this one. Okay. So if we have two resistors and above, I mean 3 resistors and above, so we have to use this formula. Okay. So 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. And then you will already be able to get the R total. Okay, so that's for the R total. And then once you already have the R total, then you can now use the I. So for the I total, you can use the I divided V divided by R. Okay, and then you will get this one right. And then for the I sub 1, so from here we have VR1 divided by R1. Okay, so as long as you know the value of your VR1, wherein you already know since it's in parallel connection, so whatever is your voltage, total voltage, that's already your VR1. So VR1 is equal to 12 divided by R1 which is 11. So from there you already have 1 point something. Okay. So just keep on doing that one. So I2 is of course VR2 divided by R2. 12 divided by 7. Then you will get 1 point something. Okay. Up to I3. And then for the VRs, okay. So very, very simple since this one is in parallel. So V total is equal to VR1 equals to VR2, etc., etc. Okay. Up to how many resistance you have. So yeah, that's the answer or the solution for the question number 7. All right, so we have 8. All right, so we don't have enough time anymore. So we'll just continue this one on the part 2. All right, so goodbye for now and see you guys on part 2.
Bye, sir.
Goodbye.
Bye, sir.